I welcome all the participants and the resource person for the today's session on emerging technologies. I am glad to introduce our resource person, Mr. Selvakumar Panneer, Senior Graphic Software Architect, Intel. He has 20 plus years of professional experience in GPU driver development, 3D graphics and interactive graphics research. He has 11 patents to its credit in the areas of augmented reality, ubiquitous computing, interactive display surfaces, computer vision, parallel processing, dynamic kernel modification for GPU, and so on. His innovative ideas on GPU performance optimization and power savings are incorporated in AMD GPUs, Intel processor graphics, and Windows 10. We welcome you, sir.
Thank you so much. Let me try to share my slide and let's see if we can do that. Let me know if you can see the slide. Is everyone able to see the slide? Can I start?
Not at it's in.
Okay, I see some echoes, so if people can go on mute, I think that might help. All right, I'll get started. So thanks for inviting me here, and this is wonderful to give a talk to such a broad range of audience. So this is my first time giving it online, so bear with me if there are some hiccups as I present the slides. And so my name is Selvakumar Panneer. I'm from Chennai as well. I moved here back in '98, so it's been about 22 years in US. And I live in Portland, Oregon. I'm giving this talk about 13,000 kilometers away. So it's interesting to kind of give this talk from such a broad audience here now. Um, so I think one of the thing, as I was introduced, I've been in this industry for almost 24 years now, and my primary passion is on graphics. Even after all these years, I'm still passionate about graphics and still trying to do research in that field. And my primary focus is to look at things for the future, how we interact with the computer and how do we actually visualize things in the future. So, mostly my time is spent on development and architecting software architecture, and some of the technologies are, as I mentioned, was introduced and is now part of Windows 10 as well. So, and part of the thing that I usually normally do is when I visit India, I give talks, and so like I mentioned, this time it's over online. So hopefully this will be fun as well. As you see that my target, my career started as a game developer. I started my career in Chennai, a startup company that started game development back in mid '90s, and then kind of came to US and started working on game companies here as well, and then slowly moved into Intel and started leading teams. And mostly focused on performance on GPUs, and more recently, kind of looking at the research side of it. So that's more of an introduction. Today's topic, I want to just give a quick overview of things that are happening. And as everyone is aware, this is a pretty hard time. There are a lot of concerns from students, especially on what the future is going to be, especially for folks that are completing their bachelor's and heading to US for master's, or people who are kind of into job market, like trying to look for to decide what is their career is going to be. So hopefully this talk gives some insights into things that are happening as we speak, things that are starting up as well. So maybe this talk can give you some pointers to setting up your career or where your direction you want to set for your higher education as well. So and we'll hold the questions till the end. Hopefully that's fine. And we can probably have some time to dedicate it for just for Q&A after this talk. Um, so I want to start with the evolution of computing. I don't want to bore with this topic, but one thing I want to bring up is the last 30 years. What are the big innovation that happened, and how do we see that, and how can we predict the future as well, right? So we'll start from the modem that was introduced in the 90s, and then one of the things that happened was they started noticing that programming should be somewhat convenient for people. So Java kind of broke that. And as we go along, years passed, every new technology unlocked another technology. So, for example, social media was introduced a long time ago, and then that gave way to smartphones. And then smartphones, people started using smartphones, and because of that, like the cloud computing is another thing that kind of started early. And as we see, I mean, over the last, so like I said, like 30 years, there are big transition happened, and I would say in the last 5 to 10 years. The moment in 2012, 11 timeframe when big data was kind of introduced, many of this were just theoretical ideas, right? People thought like, what if we have ubiquitous computing power? What if we have enormous storage? But most of those theories started happening in real. And as we go forward, things got even further as well. Technologies are now part of our body. Wearable technologies showed up, and that took a while. But then once it started showing up, and that tried to help people to stay smart, like have technology in their hands. But then more recently, in the last 5 years, I would say smart homes started picking up. And so from kind of having wearable technologies to bring information close to us, we started making homes smarter as well. So there are a lot of technologies towards that. To IoT started more relevant now with the smart home technologies. And one important thing that I personally liked is the drone. This is the way I see it is like that was the first time we put computer to fly. So we can think of like drones that can carry compute and camera, and it can literally see from the places where humans normally don't see, like from up from the top, how things are, right? So, and deep learning, I would say that around like 5 years ago is when it really kind of started showing that. Again, this is more of this what if. Sorry. So again, this is one of those what if questions that got answered. Like, what if we have enormous power where we can compute and have machine learn? And 2015 is when that became more of a reality. Mostly researchers were able to do this. And in the last 5 years, I think one of the things that the entire world is looking after is healthy lifestyle, not only personally, but also in a community-wise or in a country-wide, things are started looking towards a healthy lifestyle and trying to see if technology can help towards this healthy lifestyle too. And we are now in 2020. One of the major innovation, in my opinion, I think, is we are making cars smarter. This autonomous car, again, one of those what if, is now getting more real. Companies like Tesla and companies all over the world are trying to kind of really focus on how do we bring cars go autonomous, and how do we handle those workloads, right? So. And in my opinion, I think the future, I kind of bucketize into three things. One is the green living is going to be more of this global problem that we need to see how technology can solve it. And you already see signs of it now, like plastics are being abandoned and plastic bags are abandoned. We're trying to kind of move our lifestyle into a green living, and we are using technology to kind of assist us towards that. And another big initiative going on is smart cities. As we said, like from wearable technology to make people smart to home smart. Now, the cities are getting smarter as well. So technologies and infrastructure to make cities smarter is also something that is happening. And the last one I want to bring up is that compute is now everywhere. And anywhere you want compute, you can access it. You don't really need to walk to a computer to get this compute power. It's everywhere, and you can access it through the cloud. infrastructures, and you don't have any limitations on the throughput or bandwidth and so on. So this is to show that I think from the evolution of computing, every time one technology comes in, it leads way to the next technologies and leads way to next technologies. In the last 30 years, I feel like I think we reached a point where there are a lot more what ifs coming up to be answered, and so this is a starting point towards that. So I want to change the track a little bit to now show from a computing point of view, what are the 4 different ways now we can actually compute. CPU is one of the more common ones that everyone have probably programmed and know how to program it. But in the more recent years, GPU is becoming more and more important, not for just gaming or graphics point of view, but from the general compute point of view, GPU becoming more and more relevant. And FPGAs and ASICs were already there, but it is a little more harder to program. But from a throughput point of view, those are the things that people really go after to kind of get massive throughput. So from a programmability point of view, I can kind of put this chart to say that I think from easy of programming, CPU is easier to program, and it's much easier to program using any language. But then when it comes to the GPU, it gets a little harder and harder, and the set of languages that you use to program gets much, much shorter as we go towards the right. One other thing, as I mentioned, efficiency is something is more on the ASIC, but as I mentioned, it's also hard to program. So there's always a balance of which one do you pick. The other one is the flexibility. So like any programming language, you can actually program a CPU. So there's a little bit of a flexibility there. Most of my career in the last 25 years, or even more than that, I would say I focused on the first two, how do we efficiently program a CPU, and how do you efficiently program the GPU? And as I said, like I started as a game developer, so I started with graphics as my base. So from my early stage of the career, I know how to program the GPU more for graphics. But then now with the data parallel workloads that's showing up, that can be done through GPU, which led way to machine learning and simulations and distributed search and all that. It becomes much more relevant for me that I think the knowledge that I had in GPU is not more relevant now than before. So the other one I want to bring up is also when it comes to compute, we can think of like 2 models. One is the scale up model and scale out model. And as everyone is aware, like we go and buy better cell phones or better laptops because we want to have better performance or better capabilities, like more storage. And so it's always like a replacement model from a small unit to a bigger unit and so on. And this definitely can lead way to businesses like gaming and visual processing and VR or AR experience, where it demands for a much higher compute, and it demands for more storage to process those massive amount of visual data. The scale out model is something again most of you are aware of, but it's interesting that to think of compute as a scale out model. Now the compute, the size of the compute or the capabilities of the compute is still the same, but they are kind of scaled in numbers and connected through some connectivity layer. And so this kind of leads to many technologies like compute anywhere or big data processing and the base of cloud computing or IoT platforms, right? So this is more of a trend that I would say in the last 10 years. I think the scale out model get more and more relevant. But the one interesting trend that is going on is the fusion of these two is also happening now. Things are not just this or that, scale up or scale out. It's a combinations of scale up and scale out as well. So that is also getting more and more relevant now. And so I want to just summarize on a key trend before we go into each of the segments. And one is that data is the new gold in the technology world. Every company that you see is after data, user data. There are startups coming up that is completely focused on user data, how user behaves on certain things, and how to collect those data, how to mine those data, and how to create businesses around the data. And AI is again used everywhere, and from a research only stage now, it is really into products, and it's starting to replace, especially mundane tasks, things that humans don't really want to do on a daily basis, or now completely being replaced by AI systems. Right. And computer languages, which used to be a big thing in the past, is now slowly diminishing. When I say diminishing, it's basically the like languages like Python or things are kind of unified compute programming models. So you don't really need to kind of go really, really deep into C, C++. You do need to know that for certain fields, but the language barrier is slowly kind of going away. And cross-platform development is basically how things are operating now. Things are not just focused on Windows or Linux, and even the operating systems are now in favor of one another. So you can have Windows running on Linux or Linux running on Windows, and you can also have kernels kind of talking to each other between those two operating systems. So those are also getting fused, which is very inviting for people, for folks that are already working on Windows can actually now explore Linux more easily and vice versa. And another thing I already pointed out, compute and storage is definitely becoming ubiquitous. You don't really need to stop our innovations based on the current needs of compute, and the scale out model literally gave way to enormous amount of compute and storage. And one example I would say is YouTube. This is literally like no limit on how much video can you upload or how many views that can you do. So the compute and storage need is completely kind of wiped out from a user's point of view. And open source is shaping up the future more than ever. There are a lot of initiatives from companies. Things that are proprietary black box libraries are now becoming open sourced. And so there is already a lot of community-driven initiatives going on. So it is good to kind of, my rest of my talk is to kind of go after some of those and see how students can already, who are interested in that field, can kind of take advantage of those open source models and also contribute to that. So that's kind of how I kind of plan this talk to kind of touch each topic and then kind of see if there are interests, what is the next step? So there are definitely a lot of leading technologies. I picked some that are relevant to what I do, and again, all these topics are with respect to graphics and gaming and GPU, but it is relevant from the field point of view. These are relevant for, as a domain point of view, this is relevant for people starting their career or going towards an higher education. So big data, this is definitely not new. It's been around, but again, this is, I would say, is more of a foundation for a lot of the new technologies. Again, this was one of the first what if that got answered. And so I definitely don't want to teach about big data. I'm sure everybody's aware of it. But it's interesting to note that they always refer to us as the 3 Vs, 7 Vs, or 5 Vs. But it is it just keeps growing. I mean, this is literally a data that has enormous in size and it has in volume and velocity. I mean, it can fit in many aspects. In the end, it is just literally unmanaged amount of data, just like so much data that to be processed. And there are many frameworks. The two predominant one I would say is the Hadoop and Spark. And again, these are something people haven't started looking at this. This is probably a good time to kind of look into those and see how data are curated and searched, and I mean the whole process of big data. So one important thing I want to bring up in big data is the data visualization aspect, which is again now added as one of the V's in the big data. Visualization, and personally, I'm very interested in visualization. And now with the big data and deep learning, it is more and more relevant. I mean, it's more of a one snapshot view of the data, right? Like I would say it's an infographic view of some complex data. The top left image that I have is showing the flight patterns, right? Like the most common flight patterns. Not at this time, of course, but this literally gives you an idea of like what are the traffics looks like any given snapshot in time. And the bottom right is the one that we always see on everyday basis in use. But again, the visualization of that comes from a lot of data processing, and now it's being visualized in just one snapshot. And so folks that are interested in technology, but they also have this creative angle that they're passionate about. This is an interesting field. And there's definitely a lot of companies looking for people with the skills that can visualize data in much more meaningful way for humans to process, right? I want to bring one such thing that I typically use. It's called D3JS. Some of you may have already used it, but for me, this is the simplest of this is that it is so simple to use. The tool requires not much of learning, and it runs on JavaScript, and you can literally do everything over the browser. And it brings this amazing visualizations, and not only static visualization, you can literally create interactive visualizations, and from this raw data point, right? So, and so this is I would say it's an emerging field, and again there are companies like Tableau and others are already established visualization as part of the important technology thing. But the one aspect I see is that fits into any domain that you choose. Is that a question? Okay. All right. So the next one I want to go a little into is cloud computing. Again, this is not new. It's one of the things that is transforming the technology space. I want to bring a little more towards what is new in this field, right? One of the important things that happened recently is cloud are not only used as a passive compute, like for example, Netflix, or just streaming frames or streaming movies from a cloud service to the client. Now it is really going into an interactive cloud computing, like cloud gaming, which just showed up, like I would say 6 to 8 months ago, when Google introduced Stadia. That's one of the major turning point in cloud, where now we are not only connected to cloud, but we are interacting using cloud in a millisecond level latency. So right, so that is a very the starting point of this is that cloud gaming showed ways to bring this interactive cloud computing model. But it's not going to stop right there. It's going to transform into everything for going forward that requires interactivity or low latency can fit into cloud in the future. And serverless model is also getting more and more attractive, like AWS Lambda, and then IBM has this cloud functions. Those are also gonna easing some of the company's pain to manage servers and manage the cloud infrastructures, and these things are also shaping up. So if you're very interested in kind of transforming your future or career towards this cloud computing, which is a massive field by itself, one good thing is Amazon and Microsoft already has initiatives for students. And if you haven't already taken the initiative to kind of sign up and take advantage of that, I would definitely suggest that you should definitely look into those. And I mean, if you look at the current meeting itself, this is literally being hosted through cloud, and now more than ever, Zoom, Skype, and any meeting and all that is so relevant that we can't live without it. So it's going to be the bread and butter of technology in the future. So I would say if people who are interested in programming and distributed computing, this is really an exciting time. And companies are literally moving to everything to the cloud. So it is good to kind of look at cloud as another career opportunities as well. Again, from artificial intelligence, I don't want to bring the definitions and all that aspect. I'm sure everybody here aware of the recent trends that are going on with machine learning. I want to focus on things that are happening right now, right? What is the impact of AI? One of the things, as I mentioned, the most predominant one is like replacing mundane tasks. The things that people don't want to do, they're using AI to do it. And then predictive technologies like predicting like stock market or how the weather is going to be. Those things are also getting more and more relevant. Vision-based AI, like detections and recognitions of objects and things like that. Those are, again, the fundamentals of AI. And those are also, even though it's been many years, it still needs to be kind of perfected. The more interesting thing that are going on now is generative techniques, GAN-based techniques, and there's a lot of papers that talks about AI creating human faces and that are indistinguishable from real ones. So you can't really tell if a video or a picture is real or something is generated by AI. So that field by itself is so novel. Again, this is a very interesting time for people that are creative and want to kind of have their hands on technology like AI with GAN. That's a massive research by itself. What is the next step for people who are interested in AI or who wants to kind of start on AI? One of the things that I usually suggest to students is to kind of start looking at challenges, because that's one way to learn is to get challenged. And one such thing is already there called Kaggle, and that's the link there. This is a website where they help you learn AI, machine learning, deep learning. And I've listed like their kind of very curated process for learning, the step-by-step process of how do you become a deep learning engineer, or you're literally like to know the nuts and bolts of AI. Um, and they also host data sets that are available for people to kind of explore AI, because AI without data is meaningless. So this website is really bringing value not only from learning, but also giving all the resources for people to go explore AI. Um, and to kind of make it even exciting, they also host competitions. The slide on the right that I have there kind of list the top challenges that are running right now, and you can also see the cash prize that they offer, and this is an exciting time to kind of learn AI, but also get challenged and then post your results, and then see if you can win with these big challenges that are happening. And sometimes it goes really high value challenges that are running millions too. But many times, I mean, the people that win these challenges are really young. I mean, they come up with an innovative way to solve a problem that even some of the researchers haven't thought about. So it is always this out of the box thinking is one aspect that AI is really looking for. And so this Kaggle platform really gives that opportunity. And again, another thing that I personally kind of do is also look at papers, or kind of get connected with people who are reviewing papers. One such channel is called 2 Minute Papers on YouTube, and they review the top papers in top conferences in a very short time. So it's more of a trailer of a paper. So and if you're interested, you can go read much deeper into the paper, or even implement what has been developed in the paper. So I think, yeah, that's another very interesting thing I want to point out is that Kaggle, if you haven't started, this is definitely a good time to start. And since everybody's locked down, this is probably a better way to kind of learn something and put a schedule towards learning all this aspect. And as I mentioned, like I work on graphics, and I get excited when I see AI being used in graphics domain. And one of this video that really excited me is to kind of show this video where AI is used to kind of define the movements for this virtual character, right? Not only at like a mesh level, but every level of the body, like the flesh and the muscles and textures, and all of that is being completely generated by AI. So it also has this learning capability that it can learn, and again, from a mundane task, from an artist who needs to kind of do a animation like this would take forever to kind of do it. But now we are actually using AI to kind of get this high quality animations for movies or games and so on. So AI is not just like a processing of data and making sense of data, but there is also a creative angle to it. And this one video kind of summarize the creative angle that you can get, and it is unlimited. This people are exploring. I would say it's like basically the tip of AI. I mean, there's a lot more to learn as we go forward. Um, and one aspect I want to bring, we talk a lot about AI, but fundamentally the way computers see our world is also transforming. And this slide is showcasing that, I mean, the way computers see a real world is not just a plain 2D images anymore. So I would say about 10 years ago, the introduction of depth cameras, where the computers can not only see a real world, but it can also understand the distance of objects in real world. So like the coffee cup on the bottom left, not only they can see it, but they can also understand how far the coffee cup is. And more recently, this kind of planar images are now becoming spherical images. I'm sure many of the cell phones now have fisheye cameras. And one aspect of that is it can cover more angle than just a normal 60-degree cameras. So this is the spherical videos is getting more and more interesting. And then now it's even further, like they have this new cameras. It's a collection of cameras that can create this high definition 360 videos. And this is literally how computers are now seeing real world. And the more interesting one is they're also using technologies like multiple cameras, looking at objects. In this scene, there are multiple cameras attached to a dome, and it is seeing this real scenario happening in the middle of the dome, and be able to kind of resynthesize the scene from any camera angle. So this is another way to look at like the way the computers see real world is completely getting transformed, and it can see better than what we can see actually. So, and again, these are the technologies that are there, and again, this is going to transform even further as we go. And so because of the way computer sees, how computer is going to process them, and this computer vision field is again trying to solve that problem. And it's again, it's the bread and butter of autonomous driving and the whole AI, how computer sees and makes sense of objects that it sees, and make decisions based on the objects that it sees, right? So one thing I want to point out in this one, again, just like Kaggle for the AI-based learning, there is if you're interested in computer vision or very focused on autonomous car as your career, then there is this website called Carla, this Carla Challenge. It's an initiative by researchers where you can explore technologies that fits into autonomous car or computer vision. And then there's challenges goes on there into that as well. So you can participate in those challenges. And I do have a link that I want to show. Let me see if I can bring that up. This is the challenge, and people sign up for this challenge, and you can see it's open for the entire world to participate, and people get ranked for these challenges, and literally people from Brazil. In the last challenge, I think the folks from Brazil won the challenge here. So this is, I would say, this is another way to think about learning is to get challenged, and then probably collaborate with your other students or classmates who are interested in this, and then participate in those challenges. And one way to learn is, yeah, like I said, is to kind of challenge ourselves and then see if we can do better than what others have already done in that field. So a relevant topic to that, since it's autonomous driving, which is one aspect of IoT, but IoT by itself is also growing tremendously now. Like I said, IoT is the foundation of all the technologies, like from wearable to smart homes to smart cities and all that. This is literally going to be another way to look at how do we process data and how do we make sense out of the data. And so this by itself is another big domain. And there are companies, again, looking at people that are really puts efforts into building the ecosystem for IoT. The point here is that it's again, this is going to be the bread and butter of the technology in the future. So we can't really live without something that's not connected to the internet. Everything is going to be connected to the internet. So starting from how computers see our real world, this immersive experience is literally how humans can see virtual world, right? So, and that is also changing quite a lot. Again, these are all the what ifs that happened 20 years ago. When I started my career, the VR is literally like the holy grail. Like people were thinking that it'll be awesome to see virtual world through our human eye, like just like we enter into a virtual world. And that is what's happening now with immersive experiences. Starting from Google Cardboard, you can just put your phone and immerse yourself into this virtual world. But it didn't stop there. I mean, this led to VR experiences that I listed here. And also AR experiences. This is literally, we don't have to fuse ourselves completely into a virtual world. We can actually have this augmented world where it's a mix of real world and virtual world together. So the two things that are driving that, I would say more now, it's Microsoft is driving this, is this product called HoloLens, which is technologies that literally embedding virtual objects into real world. And this is in its infancy stage, I would say, at this point. The technology from hardware point of view needs to be perfected. Even the software side needs to be perfected. But I see the future of this is basically think of Google Maps as seen in real world 3D, where while you're driving or while the autonomous car is driving, you can see things embedded into physical world, like the middle picture there. And you can interact with it too. It's not just passive content that is seen, but you can also interact with it. And So one is to see how computer captures, another one is to see how you see the real world. But these camera technologies are also changing tremendously, not by just the quality of image that it can take, but kind of bringing new ways to capture real world, like audio. So there are spatial audios, like for example, Alexa and all those devices have spatial audio. And so the hardware, not only the software is kind of is growing, the hardware technologies is also tremendously growing to fuse these two worlds together. So that's one of the things that I want to point out here is most of the things that we talked about is software, but there's a big transformation going on in the hardware. How do we not only bring the hardware technology, but also make it small enough to kind of make it as a wearable for us, right? So and if you are really interested in kind of looking deep into like virtual world, like VR, AR, there are some tutorials that framework like Unity and Unreal have put together. And there is also like, if you want to go a little lower level, there are frameworks like Open Framework, Cinder. You can use those to learn a little more about the graphics and so on. And even to go a little down to the GPU APIs, this is literally how everything gets transformed into APIs before it can reach the GPU. I put some links there. So DirectX is something driven by Microsoft, and Vulkan is a open standard API that is driven by Kronos Group. So those things are also relevant, and having knowledge, building knowledge on how this virtual world and real world and how you blend them together is another interesting field by itself. And again, this is again, I said these are in the early stages, and it is definitely going to transform the future of how we interact with the computer. We're not going to interact it with a cell phone, but it's going to be part of our body through glasses or through wearables and so on. And I think we talked about a lot of technologies. We talked about data, but then how the new usages that it's going to transform is it's at anybody's guess, right? And right now it is autonomous car, medical research, and the last bullet that I have is the education system. Again, in this current situation, without the combination of these technologies, our education system could have had a major hit, right? Like everybody now is actually kind of studying from home or working from home. So there's a big shift happened, and thankfully we had all these technologies. So we continue our work and day-to-day schedule in the last few months because of these technologies, right? So and it's not going to stop there. I mean, it's going to keep growing. So one thought I want to bring up in the slide is to not only think about technology that it solved the current problem, but also think about how these technologies can solve some of the problem that you're going through in your day-to-day life, right? So, and then see how we can find a solution towards that too. And this is an interesting slide to say that I think in the last 20 years or so, we commanded the computer to do certain things. But the trend is now changing. Actually, the computer is telling us what to do, from like the way the wearable device is telling now it's time to walk or time to run, and you need to put 10,000 steps and so on. It is literally commanding us to lead our life much healthier, or kind of live our life much more greener, and just increase our day-to-day productivity of how to manage time and so on. So that trend is also growing, and it's interesting that I mean we are literally dependent on computers more than ever through cell phones or through wearables than ever before, right? So, and we don't know that what the interesting trend is going to be as a future. It could be part of our day-to-day life already. But it's interesting to think in that angle from an opportunities point of view. And this is my last slide. Good that I keep track of time. I want to give at least 15, 20 minutes towards questions if I could answer them. So one of the takeaway, this slide kind of gives a laundry list of takeaways, but the key thing that I normally see from freshers or people that are trying to start their career is they go deep into one field, but they miss out on the programming aspect of it. So so it is key, in my opinion, that it'd be good to kind of learn some of the programming language aspect of it, and then not from a theoretical point of view, but also a practical aspect. So I picked like it'd be good to kind of learn at least one scripting language. Anything Python would be ideal. But then also one programming language, so you know exactly how to program the GPU or CPU and so on, right? And also I mentioned a couple of times, but compute and storage is going to be ubiquitous. So I think if you're looking at opportunities, you need to focus on things that are challenging beyond compute and storage aspect. Cross-platform development is definitely a must as things are getting fused. Like I said, OS is now becoming transparent. And so any development that you do or think about career opportunities, it'd be good to think about from a cross-development, a cross-platform development. So when I say cross-platform, it's basically writing code that can work on any language, or sorry, any operating system. And another thing that I personally like when people do is GitHub accounts. And that shows that you're committed to kind of learning something, and then you're also kind of exploring few ideas. So GitHub account would be really ideal to have, and then also kind of make progress towards kind of projects that you work on, and commit and any kind of contribution you're giving to the open source community. I already mentioned about data is the new gold, and major companies are relying on data. And one interesting fact I can say is that Amazon may have a better idea about human behavior than Google, because they have much more curated data about how people buy and what they buy and so on. And keep informed. Like technology, I mean, I'm talking now about technology, but this is gonna just keep moving actually. But one interesting thing is anything you learn today, it's actually leading to the next technology. So it is always good to keep updated, but also stay connected. And so for folks who are interested in deep learning, there's a group on Facebook called Deep Learning, and it's wonderful to kind of see people post about their papers, and there's already discussions going on those papers. And it's a massive community. It's like 110,000 people or so in that from all over the world. And I also mentioned about this two-minute paper channel that brings a lot of excitement into deep learning in a much more shorter version of it. So it's easy to learn. And I already mentioned about immersive computing. This is definitely coming our way. The two worlds are getting fused, virtual world and real world. And technologies that are fusing them together is going to get much and more important in the future. And 5G connectivity, this is another aspect where 5Gs are gonna on its way, and it's definitely going to blur the lines between client and cloud computing. So we don't really need to kind of think about connectivity as an issue when this becomes a reality, right? So that's more of a message, and definitely good luck for folks that are going to continuing on the career, and also for higher education. Any questions?
Yeah, there are few questions like, what is AISC?
What is It's a ASIC. It's basically a fixed function logic device,
AIS.
and it's hard to program them. But it's for example, Google came up with this TPU, tensor processing unit. It's a fixed programming logic, a fixed logic where you can get much higher performance. It's hard to program. It's just basically a fused logic in the circuit.
The next question is, as civil engineer, can I use AI to create 3D
Yeah, there's a
images of a
lot of
building?
research. UW and few universities have done it. So they use AI for measurements, and they use AI for interior decorations. And yeah, civil engineering, both from, I mean, it's from, pun intended, like from the foundation. I think the AI is a key part of civil engineering. And yeah, there are definitely a lot of papers that looking at real world data and just generating models actually. So just give a few for pictures of a of a house, and it will automatically create models. And there's a field called photogrammetry that if folks are interested in the civil engineering, they should look at this field called photogrammetry. That is kind of now transforming to just if I take a couple of clicks of a house, it automatically creates a 3D representation of that in 3D. So yeah, it is more relevant, I would say, and there's a lot of work going on in that field. So.
Can you elaborate on 2-minute papers?
So, 2-minute papers. This is a researcher started with what he does is he takes a paper and then he talks with a lot of excitement about the key aspect of the paper. So, for example, if there is a paper that talks about the generative techniques where they were able to generate human faces using AI. So he reviews that paper and then he gives a very cool highlights of those paper. Yeah, I think I would say if you go to Google, sorry, YouTube, and search for 2-minute papers and subscribe. I think every week a couple of papers he reviews and then he gives feedbacks on it. He also posts a link to the paper and then the key results. So it is always exciting to see more of a trailer version of a paper before you deep dive into that paper.
The next question is, what is good platform to learn about ML and AI?
Good platform, I would say. I mean, the Kaggle is, I mean, something that can run anywhere. It is literally like a browser base, so you don't really need a platform or anything. But say if you have a browser, you are already connected and you can start learning actually. So that's how simple it became right now. And Kaggle also has a list of curated content to start learning, starting from Python. So if you haven't done any coding before and want to start your career on deep learning, I would say there is a section in Kaggle for learning. Maybe let me see if I can go there and then show that as well. So there is a learning section, and literally once you sign up, you can start learning. So this is the where they have a list of courses. So you can start from your Python and then kind of go all the way down to data visualization, deep learning, and then all the way down to kind of how you use AI for reinforcement learning and so on. And then there's also data that you can use. There's a massive amount of data. So if you see here, there's the COVID-19 data is now published. And so if you're interested in doing some data mining or AI on top of this data, those are available to kind of explore. And and the compete section is where they host competitions and the cash prizes. And once the competition is complete, they also post the results. So even if you're not interested in participating, you can also go review the completed competitions and see how people solve problems using AI, which is another way to learn, is to understand a problem and also see how people solved it using the novel techniques. And so now you can learn a lot by learning what others have done to solve the problem.
Which is better to use, Python or R?
I think it's depending on your personal interest it's I think it's something personal to you which one you prefer. But one thing I see is Python is genetic enough that it can run on anything, there are platforms that automatically adapt Python very openly too. So I haven't used R, so I can't comment more on that. But I've used Python extensively on projects that requires very low latency and high throughput to something that's very simple enough to use. So I think personally for people who are using R, maybe they should give it a try on Python and then can evaluate. But it shouldn't stop one or the other. I would say if there's given opportunity, learning both is better. But if you're starting new into programming or starting your career into something into programming, I would say Python is probably a good starting point, and it's open source, and it just has a lot of community backing behind it. And there's a lot of support online as well, which is more important as well. So personally, I haven't used R, so I cannot comment on the community backend. But Python is a massive backend on the community.
The next question is like, which website is can be referred for learning graphics?
Learning graphics. So the ones that I've listed is definitely a good starting point. So I've listed Unity 3D and Unreal. So Unity 3D is definitely a simplest option, I would say. So if you already know C Sharp or JavaScript, you can start coding and you can start learning graphics very quickly. So these are at the very high level actually. So when I say graphic, when the question is about learning the fundamentals of graphics, then I would say we need to go a little deeper into that. But for understanding graphics at a higher level, Unity 3D is definitely a good starting point. Unreal, on the other hand, you can start at a higher level, but you can also go down to understanding the concepts of graphics rendering and so on as well. So, and there's another one called Cinder, which is also I listed here. It's another open source project, which also has a lot of samples, and you can learn graphics using by kind of going through those samples as well. And there are Coursera has a lot of courses and about computer graphics. And the thing about graphics is it never changed much from the technologies behind graphics. Like there are two technologies, ray tracing and rasterization. What really happened now is, again, this is more of this what ifs are now getting answered. Now people are using GPU to render much faster. So the fundamentals of graphics are embedded into all these links that I've given. But to start with excitement, Unity 3D, you can start learning graphics at a very high level. You can even create a game without writing a single line of code. And then go down into understanding how the rendering happens using the Unity 3D. And both listed tutorial sessions to kind of walk down into the whole graphics pipeline and how to render things and so on. The lower level APIs that I've listed on the same link also gives you low level details about how to program a GPU to render something. Right. So that's why I listed them from a top level to understand top level. The general and graphics creative frameworks are more at the mid level, I would say. And then the low level is kind of to get to the lower level APIs that are needed to render graphics. Right?
The next one is Nimble AI platform is better one for coding online.
I think coding online is much easier. You can share your code. So my personal interest is to kind of keep it online, so you can code anywhere. And Jupyter and those things are also embedded in Kaggle, so you can use them anywhere you want, and also share your code and have collaborate with others. So that's one thing I emphasize is to not to kind of solve problem in isolation, kind of collaborate with others, and others could be your classmate or it could be somewhere someone around the other side of the world. Uh, so personally, I think I would keep it simple for development in AI, and Jupyter is again embedded into many platforms, and so it is easy to set up and run.
Can we register patent for mobile applications?
Yes, I think if there is a novelty aspect that never been patented before, it is definitely good to think about patent when you're writing applications. Again, this is there are two ways you can patent too. You can actually have a provisional patent, so you have a year to evaluate before you really go for a patent. So that's another thing to look for if you're writing applications and you think it is novel. And no one have done it from the core novel concept of the application, not the application itself. What is the novel aspect of the application? Then that is definitely patentable. So,
Now everything has become smart, so it requires much bandwidth signals to work on. Going
mhm.
on up to 4G, 5G, and so on. How to be secure ourselves from signals for healthy lifestyle?
I think there's a lot of controversy around that. And yeah, I think it comes from the signal strength and other aspect, which is not my area of expertise, but from the trends that are happening, I mean, that's something to look for uh, the signal strength. I mean, what are the policies that the state mandates or the government mandates for each of those signals? And in some cases, those are not followed, and this is kind of what the after effect of it. So, in my opinion, I think, I mean, I would say I'm not into that field to answer that in a right way. But I think, in my opinion, I think it all comes down to the state mandated or government mandated policies around those signals, right? So,
Which language is better in 2020 to learn?
a very, very good question. I think for beginners, I would say start with Python. That's a very starting point for to see how to program something. And interestingly enough, kids here, even in their fourth, fifth grade, they are learning Python, and they're looking at using. Like Lego code blocks or Arduino to kind of program simple things. So I think the key is something that is easy to program. Is I would say is the first starting point. But my personal preference is to kind of keep it open. I mean, I've done coding in everything, like starting from Java to C++ to C Sharp to Python to everything. And it's more about which programming language to pick to solve one problem. But to go to the nuts and bolts of programming, my personal preference that I would advise people is to learn C++. It is the core of a programming language, because I've used that long enough. And I'm still passionate about how the C++ community is kind of driving towards a secure C++ platform. Before it was a little more open, but now, again, back to the question about security, the programming model itself is building security. The C++ standards are towards that. So if you're a beginner, start with Python for sure. There is also a lot of interest in a language called Rust, which is another new language that is also more towards developing something that's a little more secure enough for more bulletproof, I would say, in terms of code execution. Um, but I would say keep your option open, but start simple and use programming language more as a weapon to solve a problem. And you need a lot of weapons to solve the problems in the future.
What is Spark AR?
Spark AR. Is that something that I mentioned? Spark AR. Did I say that anywhere here?
So we have a question like, can we use Spark AR to create Instagram AR filters? Or is there any
Oh,
other better software for making those filters?
oh, I see. I haven't used Spark AR, so I was like, wow, did I mention anywhere that I'm not aware of? But yeah, these filters. I mean, there are companies that are creating filters, but the true AR comes from a lot more understanding of the physics of the real world. So the one that we see from mobile phones, those ARs are. I would say it's more from the entertainment aspect of it, but not from really fusing virtual real world with virtual objects. So the part that I mentioned AR here is for us to not to even believe that the object in front of you is real or virtual, right? That level of quality of rendering. And AR comes from truly immersing the virtual object into the real world scene. With respect to lighting and everything, it has to mimic that it is really there. So I don't think the filters and other things, in my opinion, or at that stage, like the one that HoloLens is looking or trying driving towards, is to bring that kind of true AR experience, where it is literally hard to tell which is real, which is virtual on what you see.
The last question is like this. Uh, how to ensure the security for open source tool to work on live data?
Yeah, this is a very, I mean, a good question again. I mean, good that people are thinking about security because that's going to be an ongoing issue, not only for securing data, but even from a machine learning aspect, to securing the models and then the weights and training data and all the data sets too, right? Like, because we don't want people to steal any one of that, right? Because it just basically one if one piece of the puzzle is leaked out, I think the whole solution falls apart. So securing that is again is definitely a challenging. Many companies, cloud providers, are working towards that model, like serverless, FAS, and the function as a service, and all that are trying to solve that. But there is also, initiatives to look at deep learning models that really work on secured content, like encrypted content on an encrypted network, right? So it is like nothing. The training, everything has happened in an encrypted world or encrypted setup. So again, it's a very challenging subject, and I don't have a real one answer because it shouldn't have a one answer because again, if that is a one answer, that is hackable as well, right? So it is by its own domain a field that needs to be evaluated as a security for data and privacy, right? Or again, the data is a new goal, but securing that, I don't think there's one solution fits all, and it depends on the scenarios, usages, and so on.
Okay, we have come to the end of the session. Uh, HOD ma'am, are you there?
Ma'am, yes, ma'am, yes, ma'am. Good morning,
Shall we?
all. Yes, ma'am. Shall I conclude, ma'am? Jnanapriya,
Ah,
ma'am.
yes, ma'am. Yes, ma'am.
Uh, Good morning, all. I thank our management and principal for their support to organize this webinar. Mr. Selvakumar, sir, we had a great session today on emerging technologies. Thank you so much, sir, for accepting our invite and for this wonderful session. Dear participants, thank you so much for your overwhelming response and active participation. I thank Jnanapriya ma'am for organizing such a wonderful and useful session. Thank you, ma'am. I thank all
Thank
my
you, ma'am.
faculty for their coordination and support. Thank you.
Thank you so much. Yeah, this is great to kind of be here and give a talk to such a big crowd of folks from different domains.
And
So
yes, sir, we
thanks for
had really a very good and useful session, sir. With a
thank you
special
so much.
thanks to you, sir. And we know you are a friend of Jnanapriya, ma'am. And
Yes,
thank you, ma'am, for such a wonderful session.
yes. Thank you, Nanapriya. Definitely, it's a thanks for the
Thank you,
opportunity.
Selva, for accepting the invitation. So, one thing I would like to share when I asked, can you give in a seminar in a open forum like WhatsApp group, he immediately accepted saying, I'll do. It's my time to give back to my community. Thank you, Selva, for your.
Yeah, yeah. You're welcome. Thank you so much. Yeah.
Thank you. Thank you. Thank you, participant, for your support and cooperation. Now, feedback link will be posted in chat. Kindly fill it to get your certificates. Thank you all.
Yeah.
Thank you. We are
Thank
ending
you.
session. Dear participants, fill the feedback. Thank you. Thank you, Selva, sir.
Thank you. Signing off. Thanks. Bye.